All right. So last week, before you guys left for the weekend, I gave you a quiz to do that I wanted you to do that night, but I didn't grade it right away. So I actually just graded it before class, and I saw that there were quite a few students that actually didn't turn it in. I don't know why they didn't turn it in, but unfortunately, it's going to be a 0. So I do plan to give you a lot of quizzes for the next couple of weeks because Chapter 4 is actually something that is important you need to know Chapter 4 before you go on to the second part of this course. So that is something that we're going to be focusing on. So I'm going to go and since I've already graded everybody, I'm going to go ahead and write this out. So it says, write a class for a coin that has instance data for face value, let 0 be heads, 1 be tails, create a constructor that initializes face value, and then getters, and then setters for face value, a method to flip, and the flip method should randomly set a face value from 0 to 1, and override the toString method. And then I also tell you to write a driver class. So a driver class is a class that has the main method. So that's kind of like, if you guys remember, the main method is the entry point for a Java program. So it's the class that is going to actually drive the program, where the coin class is the class that is going to hold the data and be the blueprint for our object. Okay, so I'm going to go ahead and create that. I'm going to hop over here to Notepad++ and save this as coin. I'm going to go ahead and put this into Dropbox. Dang it, what the heck? I didn't mean to do that. All right, so in Chapter 4, I'm going to put the coin class. Now, if you actually have the book, there is an example in the book of the coin and also the die. So both of these classes are actually in the book. I'm going to save this as a Java file. Okay, so the requirement was that I wanted it to be coin. I know some people named it something different, like Flipper1 and Flip Data. Like, I have no idea why you chose those names, but just like our coding standard says, you should give your class something meaningful. So you want the name to be meaningful. So this is representing a coin. So, I mean, the perfect name for it would just be coin, right? But I didn't take any points off for naming it something other than coin. But I just kind of left a comment on your quiz that I think coin would probably be the better name to use. So let's go and write this. So public class coin. Okay, we're going to have instance data for the face value. So I'm going to say face value is this. Some other things that we want to do, oops, hold on, I forgot the data type, is we want to make a constant. I mean, you don't have to do this, but I'm going to do this the most correct way. So let's go ahead and make a constant. It can be public because it is a constant. I'm going to say public int, and it's going to be, public final int, and it's going to be the number of sides of this coin. Okay, so I'm just going to say sides is equal to 2. And then the other thing I told you to do is inside of the constructor to initialize the data. So here is my constructor, and I'm going to say face value is equal to 0. Okay, and then I'm going to make getters and setters for face value. So public void set face value. Okay, so set face value is going to take in an integer for the value that you're going to use, and we're simply just going to say, okay, our face value is going to equal to the value that is being passed in, and then public void get face value. I'm sorry, I said void. It should not be void. It should be int get face value. And you're simply going to return the instance data face value. All right, and some other methods that we're going to have to write is the flip. So I'm going to say public void flip, and this is randomly going to flip the coin, right? So I'm going to say that heads is going to be 0, tails is going to be 1. So up here, I'm going to go ahead and just define those values. Just for good measure, I'll just say public, final, int, heads value. And I'll just say 1, and public, final, int, tails value. Actually, I think I said head should be 0, right? And tail should be 1. All right, so flip, what I'm going to do is I'm just going to say face value is going to be equal to, you can use the random class to generate a random object. That's probably the easiest thing to do. The other thing you can do is you can use the math class. You can say like math.random, which is going to give me a random number between 0 and 0.99999. If I take that and I multiply it to the number of sides that I have, then I'm going to get a number from 0 through 1.99999. Then if I were just to cast this to an integer, then I am going to just get 0 or 1, which would be in the range of my coin. Right? Does everybody agree with that? So math random gives you a random double from 0.0 to 0.999999. Multiply it by 2, which is my sides, then that means the value is now 0.0 to 1.99999. And if I just cast that to an int, then you drop off the decimal places, and now your only possible values are 0 or 1, right? So like I'm randomly choosing 0 or 1 with what I did right here. Okay, and then the next thing I'm going to do is create a toString method. So public string to string, and then you return a value of this object, right? So with the current state of the object, I saw some people just print out the face value. I like to do string.format. I mean, that's just one of the things that I like to do just because I can see the format of my string. So the things that I like to do is I like to say, okay, well, it's a coin class, and I want to know what the face value is. And then wherever the face value is where I'm going to inject my numeric value. So the way the string format class works, or string.format method, is you create a string, and then you have like these placeholders of where you're going to put data, and the data I'm going to put is face value. Okay, and that's really all you had to do for the coin class. It was written almost identical to the die class, and you could have probably just copied what you did for the die and just kind of changed up some of the names and tailored it to be a coin. So the next thing that I wanted you to do is just make a driver class that instantiates a coin object and test its methods. So I'm going to go ahead and do that. So I'm come over here, new. I'm going to save this as coin test. So in here, because it's a test, I'm not going to use the scanner or anything like that. I'm just going to instantiate the object and just see if I can flip it and call some of its methods. So I'm going to say public class coin, what the heck, test. All right, and then public static void main string array arguments. And then in here is where I'm going to instantiate a coin object. So I'll just say coin C is equal to new coin. All right. And then what I'm going to do is I'm going to first thing I want to do is just print up my object. I can do that by just passing my object to the printline method. And what that's going to do is call the toString method. So if I open up my console and change directory to the folder that I'm working out of, all right, I'm going to say Java. So I guess the cool part, I don't know how cool you think this actually is, but when you have two files, if you have one file referencing the other, when you run Java-C, Java's going to compile both of them, right? Like if I were to, before I even run any commands, if I were just to type the command dir, you can see that I have my two coin classes in here. I have my blueprint for my coin object, and then I have my driver. There is no .class file in here because we haven't compiled this yet. So if I clear my screen and I run the command, I don't know why I'm doing up arrow. If I run the command javac coin test.java, it's actually going to compile both of the files. If I were to do dir, you can see now that there's the class files for the coin and the coin test, because inside a coin test we referenced the coin class. So Java knew that I had to go compile that class as well. Okay, so let me just run this really quick. So Java coin test, when I run it, you can see I have a coin, the face value is 0. So I want to test some of these methods. So I want to just do c.set face value, and I want to set it to 1, which is tells, and then I want to do another system.println, but instead of doing system.println where I pass in the object, I want to invoke the method get face value. Okay, and then I'm going to do this one more time. Okay, I'm going to set it to a value that doesn't make any sense at all, like -999. Okay, save that, come over here, compile, and run, and you can see that I did, like, me setting the face value did take, but what also took was me setting it to -9999. So in this situation, it is okay because technically we have not covered chapter 5 and 6 yet. But if we have covered chapter 5 and 6, you can update your getter to actually make sense, right? So we don't want our face value to be set to something that doesn't make sense. So I can use an if statement right here, and I can say, okay, we'll only set face value if the value being passed in is equal to the heads value, or it is equal to the tells value. Okay. Oh, okay, thanks. Okay, so I had 3 equals. Okay, so I'm just basically what I'm saying is I'm only going to take in a value if it's a heads value, a 0, or a tells value, a 1. Anything else, I'm just going to completely ignore. So if I hop back over here and I run my compile, and it didn't compile get face value, what the heck? So did I misname it? No, it looks the same. What the heck? Hold on, I probably missed a curly brace or something to make this not work. Let me save that, hop back over here, and look at my, oh yeah, look what I did there. So like that little mistake like made it seem like I had all these errors in my code, right? So I opened and I closed my curly brace on the same line for some reason. And that caused this class to be super confused, right? So when I went to compile, I had like all these error messages. Okay, so be careful when you use the curly braces. I'm going to go ahead and delete this one right here. I'm going to go ahead and save it, and then hop back over here, clear my screen, compile, and run. All right, and you can see wow, when I enter in -999, the value doesn't actually take. Okay, that is something optional. I'm not going to require you guys to do that on your homework, but I just showing it to you because pretty soon, like in a couple of weeks, we will be in chapter 5 and 6. And then it will be a requirement to use setters that actually filter and maintain the integrity of your data. All right, so the last thing I want to test is the flip method. I saw that some people were using if statements, or not if statements, but for loops to test the flip. I'll do the same thing. Again, this is not something required. If you just wanted to flip a few times, you can just do c.flip or c and then call the flip method, and then do a print. I'll just, okay, and just say I'll just flip my coin 5 times. Okay, and there's me doing it 5 times, and I just want to see what the values are. And now I'm going to come over here, clear my screen, compile, run, and you can see I flipped, and I got tells, and then 3 heads. If I run it again, I get 4 tells and then 1 heads. run it again, right? You can kind of see that it's being randomized, but that is what you're supposed to do for this coin class. Okay, any questions on that? All right, so I'm going to hop into the lecture, but before I hop into the lecture, I want to go over another example. So let's think about another class that we can write. Let me get my pen that I use. All right, so I'm gonna try this. I'll keep using this until I get better at this whiteboard thing. All right, let me see. Wait, no, dang it, I have no idea what I'm doing. How do I go back? Oh, right here, back, okay. All right, so let me create a new one. All right, so what I wanna do is I wanna write a class for a square, okay? So let's think about what a square has. Does anybody know what a square actually has? Like what data a square has? Yeah, so what measurements does a square have? A length and a width. Okay, well, that is true, but since technically a square's length and width are equal, we only really need to store one value, right? The length of a side or side length or length, right? And they're both the same because the entire definition of a square is that both sides are equal. Okay, so we can have this class called square. Okay, and the only instance data it has is going to be length. Okay, all right, so with that only value that we have for a square, like what are some services that the square can provide? So by services, I mean what methods can we create that we're going to want to invoke through our square object? Anybody know? Okay, getting area is actually a really good one, right? So finding what the area is, I agree with that. So maybe we have one called calculate area. Okay, that's a good one. What else? Perimeter, okay, yeah. Okay, anything else? Any other services that kind of correlate to length? Like getting and setting length? Anybody know? Like method that we can use to get and set length? How about our getter and setter, right? So for every instance data that we create, like what we did for our face value, we need a way to set it and a way to get it. Like what if we want to just change the value of our length, right? Then we want the ability to set that value. We also need the ability to get that value as well. Otherwise, there's no way for us to tell what the length is. So in addition to these services here and here, which are really good services, we're also going to need to provide a way to get the length and set length. And then it's also a good idea to do the toString method. Okay, so here are all my services right here. Services are the methods, and then here is my instance data. Instance data is values that are going to be associated with the square, meaning if I were to instantiate an object of the square, I'm going to have to give it a length, right? So just say I create a square object, my first square has a length of 5. I create another square object, that square has a length of 3, right? So the instance data is the data that's associated with that square. The squares are using the same class to define itself, but they both have different instance data. Does anybody know why it's a bad idea to have area or perimeter as instance data? I have length as instance data, but why don't I want to do perimeter or area as my instance data? Yes. Okay, that's exactly right, because perimeter and area are dependent on length. So if I ever change length, then I'm going to have to go and update perimeter and update area. So it's something that I do not want to retain, right? I can just make a service that is going to give me my area and my perimeter on demand from my length. Okay, that's why I didn't do that. Okay, so just as a quick example of doing this, I'm going to go ahead and just type this up really quick. So I'm going to hop over here, and I'm going to make a new file, and I'm going to save this as square. And this is a Java file. All right, so I'm going to say public class square. All right, and I'm going to have instance data for length, so that's going to be integer. Or I guess it doesn't have to be an integer. We can make it a float. All right, so we'll have our length a float. Okay, now I'm going to have a constructor. I'm going to do a little something different with my constructor this time. Okay, so what I'm going to do that's different with my constructor is instead of having a constructor that doesn't take anything and just blindly like just sets length to like 0, initialize it, I'm actually going to I'm going to say whenever you create a square object, you need to give me a value for my length. So I'm going to say float L for length that's going to be passed in, and I'll say length is going to be equal to whatever value that is passed into my constructor. Okay, the obvious ones are the getters and the setters. So if we have instance data for length, we should have a getter and setter for that as well. So public void set length. And what set length is going to do, it's going to take in a float value and, oops, that's a 1. And set my length equal to the float value that is being passed in. And then I'm going to have a method to return my float value. Oops, what am I doing? Okay, and then I have my equations for area and perimeter. I'm not going to do those. That's actually going to be something that you're going to do as a quiz later. So I need methods. I'll do like a to-do. Add method to calculate and return area. Okay, and I have another to-do, add method to calculate and return perimeter. All right, and then the last thing is the toString. So public string to string, and I'm going to return string.format. And I'm going to say this is, I have a square, and inside of my square, I have a length. And my length is going to be %f for floating point, and I'm just going to put my length right there. All right, so we created this square. We decided that the only instance data it needs to keep track of is length. Now we said that we want a constructor. Whenever we create a square object, we were going to force them to give us a value for length, and then we have a getter and a setter for length, and then eventually we're going to write methods to calculate and return area and perimeter. But we'd also want a method that is going to give us a string object to give us the current state of our square so that we can see like what the values are for our square. So I'm going to come over here and make a new class called square test. So I'm going to create a new one, and I'm going to save this one as square test. And this is a .java file. So this is my driver class. So public class square test, and then public static void main string array arguments. Okay, so the first thing I want to do is I want to instantiate an object of my square. So I'm going to say square, and I'll say S1. I'll make a couple of squares is equal to new square. There is my constructor. Now I'm going to go ahead and try to compile this, and we'll see what happens. Okay, so I'm going to go ahead and clear my screen, and I'm going to say javac square test.java. All right, so it didn't compile, and the reason why it didn't compile is because I'm using the constructor wrong. I tried to create a square object by making a constructor that takes no values. But if you look at the error that I got from the compiler, it tells you that it requires a float. It didn't find a constructor that takes no arguments, okay? So here it's telling you exactly what happened. If you look at the way we defined our square class, because I wrote my constructor to take in a float, you have to pass in a float now whenever you instantiate an object of the square. So I'm gonna go over here, I'm just gonna say, okay, well, 5.7. Hit save, and now what I'm gonna do is I'm gonna clear my screen and compile, and I get a similar error, okay? This time the error is telling me that there's a possible lossy conversion from double to float. Now what's happening here is I'm like 5.7 is what we call a double literal, which is a 64-bit floating point value. I defined my square to take in a float, which is a 32-bit floating point value. I'm going to have to force this value to be a float and not a double. And the way that I write float literals is using the lowercase f or the uppercase f at the end of my value. And this tells Java to treat 5.7 as a floating point value. So now when I come over here and compile, everything works fine, okay? So I ran into a few problems. The first problem is I tried to instantiate the object without passing any value into my constructor. The second problem is I wanted to pass in a float, or I was required to pass in a float, but I passed in a double instead. Now if I just do a simple system out print line and pass in my square, S1, you will see that you will get your two-stream output. So Java square test, oh dang it. Okay, and there is my output for my two-string. I want to just run a couple of tests on this square object really quick. I'm going to say s1.set square value, or set square, no, I'm sorry, no, it will not set square. What is it? Set length, that's what it was. Set length, and now this time I want to give it a 0.001f, and then I want to output my value. Dang it, why do I keep doing things that aren't what I'm supposed to be doing? So get length, not get face value. All right, so I'll save that, hop over here, compile, and run. And you can see that I was able to set my face value. Now, what do you think is going to happen if I come over here and try to set my face value to a negative 9999? You think it's going to take? It is going to take, right? Because I didn't really make any filters for my setter. And also my constructor doesn't have any filters as well, right? So in both places, I can take in bad data. So if I hop over here and compile and run, you can see that I was able to set my square to have a negative length, which doesn't make sense for something that has dimensions, right? There is no such thing as a negative dimension. So I need to actually create some way of preventing that. So what you would do in this situation is either or actually in both places, you can make a filter to prevent this from happening. It's not something required, like I said, because this is like a chapter 5 topic, but if I wanted to prevent this, I can say, okay, well, only take in this value if length is greater than or equal to 0. Okay, so well, can you have a 0 dimension? I don't know. You can?
It's just not existing.
But it can't be, okay, we'll just say it can be 0, but we definitely don't want it to be negative. Okay, now I still run it, like even though I updated my setter to handle this, when I come over here to compile and run, you can see that it didn't take. However, I can still come over here and pass in a negative value to my constructor and compile and run, and you can see that it had a negative value, right? Which also doesn't make sense. So I'm gonna have to do the same check in my constructor. Now, to avoid creating or like writing this filter twice, what you can do is just simply invoke set length from the constructor. Like you're basically just saying, okay, well, they're giving me a length in constructor. I'm going to pass whatever value into my set length method and hope that it handles that value. Okay. And when we do this, okay, it did handle it. It just kept the value as 0. Right. So basically what happened was in my constructor, I passed in a negative value. I called set length. Set length saw that it was a negative value and it didn't actually use whatever value that was passed in, and it just kept it as a 0. Any questions on that? Okay, so the next thing that I would want to do for this square is to provide the services to calculate the area and to calculate the perimeter. Okay. All right, let me go ahead and hop into the lecture. So let's see. All right, so like I've told you guys the last time we met, there's only 3 sections from chapter 4 that we're going to actually go over. The rest of, like half of chapter 4 is all GUI stuff, and we're not going to cover GUI stuff inside of this Java 1 course. So only the first 3 sections of the chapter 4 in the textbook is what we're going to talk about. Writing a class. Programs we've written in previous examples have used classes defined in the Java API. Now we will begin to design programs that rely on classes that we write ourselves. The class that contains the main method is just the starting point of the program. True object-oriented programming is based on defining classes that represent objects with well-defined characteristics and functionality. Here are some examples of classes. So here they're saying if you wanted to write a class for a student, the student can have a name, an address, major, and grade point average, and some services or operations that the student you can do on the student is you can set the address, set the major, compute the grade point average. Rectangle, length, width, and color, and you can set all those. You should also be able to get them as well. They're giving you an example of an aquarium, a flight, and an employee with different instance data and different methods that you can invoke on them. Recall from our overview of objects in chapter 1 that an object has state and behavior. Consider a 6-sided die, singular for dice. Its state can be defined as which face value is showing. Its behavior is that it can be rolled. We represent a die by designing a class called die that models the state and behavior. The class serves as a blueprint for a die object. We can instantiate as many die objects as we need for any particular program. As a class can contain data declarations and method declarations. So by convention, we keep the data declarations up top and then our method declarations underneath our data declarations. The values of the data define the state of the object created from the class. The functionality of the methods define the behaviors of the object. For our die class, we might declare an integer called face value that represents the current value showing on the face. One of the methods would roll the die by setting the face value to a random number between 1 and 6. We will want to design a die class so that it is versatile and reusable resource. Any given program will probably not use all operations of a given class. Okay, so here they give you the example of the way they did their die. So they have a driver class that instantiates 2 die objects, as you can see right here. And then they roll the die and they give you what the totals are or what you rolled. And here is the die class that they wrote. They have max for the number of sides, the face value. They have a constructor where they're defaulting the face value to 1. And they have a method called roll. So in their roll method, they actually return the integer they return the face value out of the method. So they gave the roll method a return type. And this is how they calculated their value of 1 through 6. You also have a setter and a getter. They don't have any protection on their setter, meaning they don't have an if statement to prevent it from being set to something that doesn't make sense. And then they defined a toString, which just simply prints out an integer of whatever the face value is. The die class contains two data values, a constant max that represents the max face value and an integer face value that represents the current face value. The row method uses the random method of the math class to determine the new face value. There are also methods to explicitly set and retrieve the current face value at any time. The toString method. It is good practice to define a toString method for a class. The toString method returns a character string that represents the object in some way. It is called automatically when the object is concatenated when the attribute is concatenated to the string, or when it is passed to the println method. It is also convenient for debugging problems. So, in the examples I've shown you so far, I always create a toString method, and then if I just output it to the console, the method gets invoked automatically. You can also, if you concatenate it to a string, the toString method would also get invoked automatically as well. So just kind of keep that in mind. And it's always good practice to create a toString. Constructors. As mentioned previously, a constructor is used to set up an object when it is initially created. A constructor has the same name as the class. The die constructor is used to set the initial face value of each new die object to 1. We examine constructors in more detail later in this chapter. Data scope. The scope of data is the area in which the area in a program in which the data can be referenced or used. Data declared at the class level can be referenced by all methods in that class. Data declared within a method can be used only in the method, can only be used in that method. Data declared within a method is called local data. In the die class, the variable result is declared inside the toString method. It is local to that method and cannot be referenced anywhere else. So let's hop back to their example of the toString. So what they're saying is, up top of your die class, you have your instance data declared, face value. So face value is declared at the class level, so it can be used by any one of these methods. Okay, but inside of the toString method, they created this variable called result, string result, and string result is what we call local data. It only exists within this method. Okay, so there's no way to reference that value outside. Okay, this variable is destroyed like once this method is done completing. Now that doesn't mean the value of the string is completely gone. If you were to actually invoke the method, you can grab that value through the return of the toString method. Instance data. A variable declared at the class level, such as face value, is called instance data. Each instance object has its own instance variable. A class declares the type of data, but it does not reserve the memory space for it. Each time a die object is created, a new face value is created as well. The objects of the objects of a class share the method definitions, but each object has its own data space. That's the only way two objects can have different states. We can depict two die objects from the rolling dice program as follows. So die 1 has a face value of 5, die 2 has a face value of 2. Each object maintains its own face value variable, and thus it has its own state. All right, let me just kind of draw something that might help clarify this. Let's see. Dang it, what did I do with my pen? Oh, it's right there. Okay, so what they're talking about is they declared a die. They had die 1, and they instantiated this object. And they had die 2, and they instantiated this object. Okay, now they both have their own face value, so these are two separate objects with different state, meaning they have their own values. So when you roll on die 1, you're actually changing the face value of die 1 only. If you roll on die 2, you're only changing the face value of die2 only. Okay, so the way that Java handles this is it sees that you want to create a variable. These are object reference variables. Hold on, I just thought of a good idea. Is there like a back? Yes, back. Okay, yeah, I'm gonna change colors when I do my arrows. I think that would be more helpful. All right, so die1 is an object reference variable, and die2 is also an object reference variable. So this part of the code, we're actually just telling Java we want to create this variable that is going to point to an object in memory, but this is a part of the code to where the object is actually instantiated and put into memory. So on your computer, you have your memory, your RAM, right? Here's your RAM. So when this method is called, what Java is actually doing is creating a space. I didn't mean to do that. I meant to select a different color. It's creating space for die1. So die1 might live right here, and then die2 might live right here. Now, what's interesting about this is this die object lives here in memory. Die2 lives here, die1 lives up here, but they each have their own face value, right? So inside of this object in memory, dang it, didn't mean to do that. Inside this object in memory, you'll have whatever the face value is. Let's say you have 5 for the face value here and 2 for the face value there. Now, they're both declared from the same class, so all that really means is the die class, which here's the file for the die class, right? This is the .java file. It's just the instructions to Java on how the die object behaves. It actually is only really tells Java, what the heck, sorry. It's actually only really telling Java, where do you go for this role definition? Let's go over here and find out what I need to do when I roll. What do I need to do for this constructor right here? Let's come over to this blueprint over here and find out what I need to do when I construct this object. But when the object is actually created and put into memory, Java is going to see, okay, well, this object has a face value, so there's this integer inside of this object that's retaining the value of this object's face value. Okay, so there's two different objects in memory. They both use the same class to define how the object actually behaves. Okay, any questions on that? That's kind of like what they're trying to portray to you. So hop back over to the lecture. Okay, so they both of these objects have different values in memory, but the die class is what actually tells Java how those objects are to behave. Okay, UML diagrams. I'm not really gonna, I might draw UML diagrams up. I'm not gonna test you on UML diagrams, but I'm gonna go and just read this really quick because I think it's important to kind of understand UML diagrams, because in the future programming classes, when you're doing more planning, it will probably come in handy. So UML diagrams, UML stands for Unified Modeling Language. UML diagrams show relationships among classes and objects. A UML class diagram consists of one or more classes, each with sections for the class name, attributes, and operations. Lines between classes represent associations. A dotted arrow shows that one class uses the other class, calls the methods. Okay, so here is an example. So here is a UML diagram for the driver class. The dotted arrow means that it's using the die class. Here you have your, up top, you'll have your face values right there, and then you'll have your methods, your services that the die object provides, the die class provides, right? Role, set face value, get face value, toString. These are UML diagrams. They kind of help like lay out and plan writing classes. So quick check, what is the relationship between a class and an object? Anybody know what the relationship between a class and an object is? So, sorry, what was that? It's the other way around. Right, so the class is the blueprint for the object. All it does, you hop back over to this drawing. Here's my class, like right here, right? Java's going to use that to determine how this die object should behave when roll is called, or when the constructor is called, or when get face value, set face value, toString is called. the object is actually just an instance of this behavior that was defined in this class, and is plopped in, and put into memory right over here and right over here. So yes, the class is just a blueprint, and the object is an instance of that. So a class is the definition, pattern, and blueprint of an object. It defines the data that will be managed by the object, but does not reserve memory space for it. Multiple objects can be created from the same class, and each object has its own copy of instance data. Just like what we did over here, we had two die objects. They both have their own face value, and they both have their own place in memory. All right, so where is instance data declared? Anybody know where's instance data declared? Well, it's in the class at the top, outside of all the methods. What is the scope of instance data? Anybody know what the scope of instance data is? Scope means like when it can be used, where it can be used. But it's used anywhere in the class. That's basically what they mean. So the scope of it is like within the class. You can use it in all the methods, where local data can only be used within whatever method it was created. So they gave you an example when they had that. Let me find their die class really quick. So here's their toString method on their die class. They created this variable called string. This is a local variable. This variable only exists within the toString method, where the entire class, right? Your instance data is declared up top. Face value can be used by any method within this class. All right, and local. Okay, so let me just read this. So instance data is declared at the class level. The scope of instance data, it can be referenced in any of the methods of the class. And what is local data? Local data is declared within a method and is only accessible in that method. Okay, any questions on the anatomy of a class? Okay. All right, so next topic is encapsulation. I kind of already talked about this, but I'm going to go through all this. It's actually one of those concepts that you need to kind of grasp. And yeah, it's just, I think it's better if I draw a picture, not because I like drawing pictures. I do, by the way, but I think these are I think seeing this picture might actually help with the idea of encapsulation. So let's consider the square that we wrote, right? So here is our square object. Here's the circle. Wait, that's funny. I said square, but I drew a circle. But anyways, the concept of a square object in memory is within the circle. So in our square, we have our length, okay? And we keep our length private. And the reason why we keep this length private is because we only want our class to manipulate that that variable, okay? We don't want anything to actually change our length to something that doesn't make sense, okay? So, dang it, I was trying to erase that. Sorry, it was just bothering me. Okay, so we keep this private, and we create something called encapsulation by making the only way to change that length through our setter. So we defined this method called setLength. Okay, and setLength, what it's going to do is our driver class. Here's our driver over here. Driver class. Our driver class is going to call setLength, and it's going to try to pass in some value like negative 99. Okay, our setLength method is going to come over here, take in that value, and it's going to do a check, right? It's going to check to see if that value is okay. It's going to see a negative 99, and it's going to say, you know what, this value is bad. I am not going to take that value and assign it to my length. Okay, so you're basically preventing this bad value from entering into your square object because it doesn't really make sense, right? But if you were actually to pass in, let's just say you pass in a 3 for your length, and you pass it into the set length method. The set length method is going to look at that value. It's going to see the 3, and it's going to say, okay, this is a good value, so I'm going to go ahead and assign it to my length. And that value that we got from the set length is now assigned to the instance data of our object. So now the length is set to 3, and we did this by creating something called encapsulation. So the idea of this is that we keep this private, right? We keep it private, meaning we can only modify that value within our class, and the only way that any client can modify this is through methods that we can create checks for, so we prevent them from getting set to something that doesn't make sense, right? So this is keeping us from setting length to a negative value. Encapsulation is also keeping us from setting our face value for a die to anything that outside of the range of 1 through 6, okay? So by making our instance data private, we only manage that data within the class, and we provide services like set length to modify these values, but we control it by putting in like if statements to prevent that from happening. So that's really the idea behind encapsulation, is you have your instance data encapsulated so that nothing outside of that class can change it. The only way to change it is through methods that you provide, right? But you define your methods in such a way to where the data doesn't get corrupted or doesn't take in a bad value that doesn't make sense, okay? So, I mean, just think about this. I mean, encapsulation is good for everything. Just say you have a student object, right? You created some grade program for a student object for like students that are going to this college, okay? You want to avoid like bad data. Let's say, I don't know, something that doesn't make sense. Let's say like your name, right? We'll say all your like names for a student are all saved into the database. Okay, you can log into some web service and you can see all your information. And there's a form that you can fill out electronically through the website to where you can actually modify your name, right? Like you can change your name to something else, but you don't like. You can change your name to something else, but you have to follow some type of guidelines, right? Like you can't change your name to like, like all integers or a fractional value or something like that. It has to be something that makes sense, right? So like they're using the same concept to where somewhere in that system, they're preventing you from setting your name to something that doesn't make sense, okay? Because they're actually taking that data and they're managing it somewhere into a database. Now somebody can try to hack the database and bypass all those integrity checks and change your name to, some value that it makes no sense for a name. Okay, but whenever we're providing our service of our object, we're taking all the precautions that we know that are necessary to prevent that data from being changed to something that doesn't make sense. Any questions on that? Okay, so that's encapsulation. Is actually, I know some people are doing like cybersecurity and all that kind of stuff. I mean, the idea is for preventative measures for things like keeping the integrity of your data from like being hacked or changed to some value that is considered to be bad, right? Okay, so I'm gonna go ahead and read through the lecture slides. Encapsulation, there are two views of an object: the internal, the details of the variables, methods, and classes that defines it; external, the services that the object provides and how the object interacts with the rest of the system. From the external view, an object is an encapsulated entity providing a set of specific services. These services define the interface to the object. One object called the client may use another object for its services it provides. The client of an object may request its services, call its methods, but it should not have to be aware of how those services are accomplished. Any changes to the object state, its variables, should be made by the object's methods. We should make it difficult, if not impossible, for a client to access an object's variables directly. This is called self-governing, okay? Managing your data in such a way to where you make your instance data private and you only provide services through methods to modify that data. An encapsulated entity can be thought of as a black box. Its inner workings are hidden from the client. The client invokes the interface methods and they manage the instance data. So like these little lollipop looking things is the client connection. So the only way that the client can actually have access to the data is through these methods. In these methods, we are going to create our conditions to prevent the data from being set or set to something that doesn't make sense. So we have these methods, and we can also get the methods, set the methods, and that's the only way the client has access to that data. So the client does not actually have a direct line to the actual data. The client's reference to the data is through the services that we provide, which are the methods. In Java, we can accomplish encapsulation through the appropriate use of visibility modifiers. A modifier is a Java reserved word that specifies particular characteristics of a method or data. We've used the final modifier to define constants. Java has 3 visibility modifiers: public, protected, and private. There's also a 4th visibility modifier, and that is the default visibility. And you don't specify public, protected, or private. And it's like kind of, I forgot the entire description of it, but if you don't specify any of these, only classes within the same package will have access to that data or to that method. But anyways, these are the 3 visibility modifiers. The 2 that we're going to concern ourselves with is public and private. We're not going to talk about protected within Java 1. So the protected modifier involves inheritance. We will discuss that later. Later meaning chapter 9 or 10. I forgot which one it is, but it's definitely a Java 2 topic. So public and private are the 2 that we're going to use. Members of a class that are defined with public visibility can be referenced anywhere. Members of a class that are declared with private visibility can only be referenced within the class. Members declared without any visibility modifier have a default visibility and can be referenced by any class in the same package. That's exactly what I was trying to talk about over here, right? So there's actually 4 modifiers here, right? Public, protected, private, and like not specifying one. And if you don't specify one, then it uses default visibility, which only within that package you can reference that. An overview of all Java modifiers are presented in Appendix E. You can read Appendix E if you want. Visibility modifiers. Public variables violate encapsulation because they allow the client to modify the values directly. Therefore, instance data variables should be declared with should not be declared with public visibility. It is acceptable to give a constant public visibility, which allows it to be used outside of its class. Public constants do not violate encapsulation because although the client can access it, its values cannot be changed. All right, let me just kind of give you an example of this. So I'm gonna hop back over here and let's talk more about this square, okay? So in my square, I'm going to create a constant called public final int num of sides. And everybody knows a square has 4 sides. So because I made this constant, I can give it a public visibility, and all that does is allows it to be accessed through the object. So I can say system.println, and I can say number of sides is, and I can say s1 dot num of sides. Okay, it is public, so I can access that value. I come over here, clear my screen, compile, run, and you can see I can grab that value, okay? Now because it is constant, right, I am not violating encapsulation. Yes?
I'm sorry, I don't know if you're going to get to that, but if it was private, would it know it, or would it?
Okay, so making this private, you can still have a private constant. There's nothing wrong with it, okay? But once I make it private, it is no longer a service, okay? So what is a service? A service are methods that I can invoke through my object or variables. So in this case, it won't compile because I cannot access number of sides anymore. Even though it's constant, I named it private, so that means I won't have access through the object anymore. The only way that I have access to this data, because it's declared as private, is only within this class, right? That's what the private does. It only says, okay, I'm making it private, so the only way anybody can ever touch this data is within inside of the square class. All right, so made it private, come back over here and compile, and it doesn't compile. It tells you right away that num of sides has private access, and you're trying to reference it right there. Okay, because it is a constant, meaning it cannot be changed, it is okay to make this public. Because if I make it public, right, I'll be able to see it through the object, but I will not be able to change it, right? Because I put that final modifier there. So if I try to modify this value and say, you know what, I want the number of sides of the square to be 9, okay? And then I try to print it out again. What's actually gonna happen is it's not gonna compile because of that final modifier. So I'll come over here, compile, and right away it tells me, cannot assign a value to a final variable number of sides because I declared it to be a constant, okay? But what is violating encapsulation is if I were to come over here and make my length public, because now, because that is public, I can now come over here and say, okay, well, I want my length of my square to be negative 1, 2, 3, 4, 5, 6, okay? And now what I'm gonna do is I'm going to print out the value of my length and hop over here, compile, and run. Okay, it did compile and it did run, but I violated what we call encapsulation. Okay, now, because I did this, that means whoever uses this object can directly modify length straight through the object, right? They have direct access to this variable. They can change this value to whatever they want. Okay, so a negative value doesn't make sense. So I basically now I'm bypassing this filter that I created to prevent my length from being set to something less than 0. Right, so that's a violation of encapsulation. So I'm gonna set this back to private. Okay, and once it's made private, I'm enforcing encapsulation. Now when I try to compile, I'll get the error that length has private access, so I won't be able to run this line of code anymore. Any questions on that? Okay, so one of the other things you can do with a constant, and I don't know if the book never really talks about this, but because this is a constant, and just say you don't care about having this access through the name of the class, you cannot make this static. Does anybody know what static means from the math class? Like when something's static?
There's constant, always,
Not necessarily constant, but
like it's set.
it's set for that class, so you don't need an instance of that object. So whenever we use the methods for the math class, if you notice, we never create a math object, right? We just call the names math and then dot the name of the method we want to invoke. It's the same concept. Making it static means that I don't necessarily need to access this through the object. I can also access it directly through the class name. I do not need an instance of that class to access that value. Meaning this will not compile, right? Because S1 does not exist at this line. It's created below this line of code. So if I come over here and I try to compile, right, it tells me cannot bind symbol. That just means you try to use some value, some variable that hasn't been defined yet, okay? But if I just say, you know what, this is a static constant, I can invoke this straight through the class name, and I misspelled square, so that's not gonna work. So I'm gonna just fix my misspelling right there and come over here, compile. It does compile, and then run. And you're able to run and get the number of sides before you even instantiate an object, okay? So making it static just means it now becomes a class variable, meaning you don't need an instance of that object in order to view the number of sides of a square.
If it wasn't static, you wouldn't be able to
Right. Yeah. Yeah, if it wasn't static, you won't be able to reference it through the class name. All right, let me hop back to the lecture. So I already read everything on this slide. To the next slide. Methods that provide the object services are declared with public visibility so that they can be invoked by the clients. Public methods are called service methods. A method created simply to assist a service method is called a support method. Since a support method is not intended to be called by the client, its method should not be declared with public visibility. Okay, so what they're talking about in a support method is, here is my Square class. All the methods I have are service methods, meaning they're intended to be called through the object, but you can define private methods, right? Let's say private void do work. Okay, so what do work is going to do is, I don't know, maybe it goes and talks to some database, or read some file or something like that. Something that you intended not to be called through the actual object. For now, I'm just going to just do like a system out print line and do work, just called I am doing work. Okay. Now, if I hop over to my Square test and I want to run that method, wait, why am I doing a system out print line? I have no idea. Sorry. So system.1.do work. I just created that method, but because I made it private, I will not be able to access that method. It will not compile. It tells you the same thing that it told me when I was playing around with my variables, that the method has private access, so I can't actually invoke that. Yes.
What exactly does void do?
Void doesn't return a value. So when you just find something as void, that means when whoever's calling that method should not expect a value to come back through that method. Right? So you can't save any result anywhere or anything like that. All right. Now, if I wanted to, because this method is declared to be private, if I want to actually call this method, I can only do it within the class. So let's just say whenever we, I'll go ahead and write this area one. So I'll say public float calculate area. Okay, instead of actually calculating the area, I'm going to just return, I don't know, a 0. But within this calculate area, I'm going to call the method do work. Okay, now do work is a private method, so it can only be called within the class, and it is in fact only being called within the class. I wasn't able to call it outside of the class, but I can't call it here. But what I could do is I can call calculate area, and the calculate area is going to call the do work, and then it's going to return a 0. Okay, so now if I clear my screen and compile and then run, you can see that I'm doing work is printed out because I invoked this method calculate area. It hopped over here, went to calculate area, it called the method do work. Do work simply just prints something out to the output console, right? I'm doing work, and then just returns a 0. That is, this is not a really good example of a support method, but that's the concept of a support method. Methods that are not intended to be services, so you make them private, and they're only called within that class. They can only be accessed within that class, just like instance data. All right, that is support methods. So here they kind of give you a box of violating encapsulation. So variables, if they're public, you violate encapsulation. If they're private, you enforce encapsulation. Methods, if they provide services to the client, they should be public. If they're support methods, they should be private. Accessors and mutators. Okay, I don't really hear accessors and mutators used very often. The name that is mostly used for them are getters and setters, right? You get your value, you set the value. Okay, I'm going to read these slides. Because instance data is private, a class usually provides services to access and modify data values. An accessor method returns the current value of a variable. A mutator method changes the value of the variable. The names of the accessor and mutator methods take the form getX, setX, respectively, where X is the name of the value. They are sometimes called getters and setters. I mostly actually hear them referred to getters and setters. So I wouldn't just say sometimes, I would say the majority of the time. The use of mutators gives the class designer the ability to restrict the client's options to modify an object state. A mutator is often designed so that the values of the variables can only be set within particular limits. For example, the set face value mutator of the die class should restrict the value to a valid range of 1 through max, which is 1 through 6. We will discuss this more in chapter 5. Okay, so I'm going to keep just throwing in whenever I write classes, I'm going to keep using if statements just because I think it's important to get used to putting in some type of restriction on your data so that you can get used to seeing your data restrictions on your setters. Like what I did here, like where a negative link doesn't make sense, so I only take it in if the value is greater than or equal to 0. Okay, here they're saying we don't really talk about it till chapter 5. It's not something I'm going to require you to do on your homework, but I'm just like, you should start seeing it now, because to me there really isn't any point of creating a setter if all you're going to do is blindly take in the value and then set it to the instance data. Because to me, that's, in my mind, that's the same thing as making your instance data public, right? So it's a violation of encapsulation to me when you don't try to restrict what values you're trying to take in for your setter. All right, so quick check. So why is face value variable declared as private in the die class? It's declared private because you don't want the face value to be accessible through the object, right? So you enforce encapsulation by making it private. So the only way to modify face value are through the methods you provide: set face value and roll. Why is it okay to declare max as a public in the die class? Anybody want to take a crack at that? Yes. Or somebody. Or exactly right, because it cannot be changed. Once you put the final modifier on there, it's a constant and it cannot be changed. So it's okay to make constants public. And then there are the answers for what we just went over. All right, so there's one more section to talk about. I'll talk about it on Wednesday. So it's actually pretty, I don't know how complicated that is. There's actually a lot to talk about on Wednesday, now that I'm looking at it. But anyways, so like I said, I am going to give you a quiz. So this is what I want you to do. This Square class is in Java. Let me go ahead and get rid of this do work so it doesn't confuse anybody. And I'm going to get rid of that as well. All right, so what I want you to do is take my Square class and my Square test class, and I want you to create the calculate area and the calculate perimeter, and then inside of your Square test, invoke those methods: calculate area, calculate perimeter. Okay. Now remember, I do not want you to make instance data for area or perimeter. Does anybody remember why? Why is it bad to have instance data for area and perimeter? Sorry, what's that? Right, because when length changes, then you're going to have to recalculate area and recalculate perimeter. So your methods for area and perimeter should be on-demand basis, meaning when you need the value, you invoke the method area, calculate area, and you actually get the area. Like, it's calculated on the fly when you need it. Same thing with perimeter, calculate on the fly when you need it. All right, so do not make instance data for area or perimeter. That is a bad programming practice. Okay, so go ahead and start on that. We do have a class coming in at 8:10. I would like everybody to at least open this up, look at it, let it kind of soak in, right, before you actually leave. I am going to grade it tonight, though. So get it in by midnight. It's fresh in your head. I want you to do this tonight. If you decide to leave, then you're going to have to go home and work on it right away, okay? After 8:10, I will move to a different classroom. I'll stick around till about 8:30 to help people, but after that, I'm probably going to take off, okay? So get this in by midnight, all right?
Graded my chapter 3 quiz. I think you quizzed it.
Yeah,
Turned it in. I think I turned it in yesterday. I don't know if yesterday was okay to turn it in.
let's see.
Yesterday afternoon. Put it in the Dropbox.
So, oh, you know what? I'm still recording. Let me stop.